और भाई कैसे हो? चलिए आज सोल्व करते हैं लीड कोड का एक हार्ड क्वेश्चन भाई। बहुत ही हार्ड क्वेश्चन है भाई। अगर तुम्हें ये क्वेश्चन समझना है तो अपना जिगरा साथ लेके चलना भाई। मतलब बहुत सारे कॉन्सेप्ट यूज हुए हैं। मतलब अच्छे से समझोगे तो काफी अच्छा क्वेश्चन है। मतलब भाई मेरे को इतने सारे एज केस थे भाई, मैं परेशान हो गया था इसको सोल्व करते करते। लास्ट में मैंने कर ही लिया। मैं बहुत ही अच्छे से समझाऊंगा भाई, एक बार मतलब पूरा लास्ट तक देखना तो तुम्हें समझ आएगा अच्छे से एकदम। काफी सारी अप्रोचेज हो सकते हैं इसमें भाई, थोड़ा एडवांस है इसमें। सेगमेंटरी, स्पार्स टेबल, रेंज, मैक्सिमम क्वेरीज, ये सब भी यूज हो रहा है। मतलब ये ठीक है, एक बार आप समझोगे तो नॉर्मल है, उसके बाद कुछ वो डिफिकल्ट नहीं है। बट समझना इसको कैसे करेंगे यही सबसे बड़ी बात है बस। ठीक है, तो क्वेश्चन वही है। पहला इसका फर्स्ट पार्ट क्या था? ओके, लेट मी शो यू द फर्स्ट पार्ट। ये था अपना, है ना, मैक्सिमाइज एक्टिव सेक्शन विद ट्रेड वन। इसमें क्या था, अपन पूरे एरे, मतलब एक अपने को स्ट्रिंग गिवन है, लाइक कोई ऐसे 0 0 1 0 0 0 1, राइट। इसके अंदर जो भी वन जो सराउंडेड है जीरो से, बेसिकली उसको हम फर्स्ट पहले जीरो से में कन्वर्ट कर सकते हैं, राइट। उसके बाद इसमें था कि जो स्ट्रिंग बनती है उसको साइड में ना वो वन से ऑगमेंटेड होती है ना, फिर जो भी वन से सराउंडेड होता है उसको हम वंस में कन्वर्ट कर सकते हैं, राइट। और फिर बताना था कितने एक्टिव सेशन हो सकते हैं। ये क्वेश्चन था एक्टिव सेशन, राइट। एक्टिव सेशन जो कि था काउंट ऑफ वन, राइट। तो यही है। आज क्या गिवन है, सेम क्वेश्चन है, राइट। वी हैव गिवन अ बाइनरी स्ट्रिंग एस ऑफ लेंथ n. Okay, we have 0 and n. Okay, we can perform one trade. Okay, at most one trade. And what do we have to do in this trade, right? Right, so first you see, right, convert a block of ones, right, that is surrounded by zeros to all zeros. If that's something that is like 0 1 0 0, right, we can convert it to 0 0. This is the this part thing. And the second part, right, convert a continuous block of zero that is surrounded by ones to all ones. That means if we have something like this, right, then these zeros we can convert back again to one. Okay, and we have given, right. Now the question asked, right, today the different thing is queries. You see this part clearly, okay. So we have given, right, a 2D array queries, right, that denotes L and R, right. Okay, so we have given Li comma Ri. Okay, now Li and Ri, what it represents? It represents a substring. Okay, now for each query, right, determine the maximum possible number of active sessions, right. For each query we have to determine the maximum number of possible active sessions. Okay, in S, making the optimal trade on the substring SLI. See, the difference is, right, we can only apply operation on S of Li to Ri. We cannot apply operation to the entire string today, and we have to do this repetitively, right, multiple times. Okay, so if we follow the by default approach, right, that is what was our default approach. So I'll add the link of the video in the very start, right. First understand that question, then you come to this question. Okay, so the approach was, let's say if we have, right, 0 1 1 0 0 0 1 0, right. See, this is left, this is right. Then for a continuous subgroup, right, for this ones basically, right, the answer will be contributed by left zeros and right zeros. Okay, so this was the basically the contribution, right, for a block. Okay, now today, right, today what is different? First is we can only apply operation on a substring L comma R, right? So if we apply operation on only this string, right, then outside this string there will be no change, right. In the end we have to tell the final number of active sessions. Okay, so first thing, right, there are, first thing remains clear, right. We still needs, right, total number of ones. This thing is clear. Okay, why do we need? Because, right, they will always be counted. they will always be counted. Now the second thing is, if we do a brute force approach, okay, if I do a brute force, then for each queries, right, for each queries, right, I take L comma R, I, right, we loop over string, we loop over string and find the possible gain basically, right? That is possible gain. Let's say delta, right? Then our answer will be count of 1 plus delta. So what will be the time complexity of this one? Queries into. Then inside queries, we loop over each string basically, right? So that is 10 raised to power 10. So this will give us TLE. Now, see, first we need to write the brute force for this code. See, once you write the brute force, you will realize what is basically happening. So let me write a brute force for you. No, let me explain you the brute force, not write the brute force. Okay, so I'll take an example. Okay, let me take this example only, right? 0 1 0 1 0. Okay, so first I'm going to explain you brute force. Okay, see, now we take the string as, right, 0 1 0 1 0 1 0, right? Okay, and what are the queries? 0 3 1 4, queries 0 3, right? Then second is 1 4, and the last one is 1 3. Okay, for each query we are going to see what happens, right? For the first query, right, we can only apply, right, operation on 0 1 0 1. This is final string. Only on this one I can apply the operation. So okay, count of 1 equals to what? 2. Initial thing I need. Then if I can only apply on this string, see, and this is also augmented. This is given in the equation. Any substring that I take, it will always be augmented. uh, you if you read this line, you see, for each query. Hmm. Okay, for each query it is augmented. Okay, right. Okay, so then on this 0 1 0 1, one operation I can apply, right? So what I can do, either I can see this, right, first one, this is surrounded by zeros. So operation 1, it can become 0 0 0 1. Okay, now since it's augmented, right, it becomes 1 0 0 1 1. These are the augments, right? Okay, then final will be what? 1 1 1 1 1 and 1. So right, this is what? 4 basically, right? And what is the contribution right now? This 3, right? Because this one we already counted, right? So answer equals to what? Right? What is the answer? 4. Okay, for this first query we get answer 4. Now we again loop for the 1 comma 4. We again start with our string 0 1 0 1 0, right? This covers the entire part basically, right? So count of 1 becomes 2, right? Now in the first operation, see, I have two options, right? Either I convert, right? Okay, see, either I convert this one or this one, right? Either I write 0 0 0 1 0, or I write 0 1 0 0 0. Okay, in both the cases, what it becomes, right? After augmentation, it becomes, right, 1 0 1. These are the augmentation walls. So if you see, right, if I then again convert, right, these will be converted to ones, these will be converted to ones, right? So it becomes 1, right? 1 2 3 4 0 5. Okay, and the second one becomes 0, right? 1 1 1 1 1. This is the last run. This is the wall. We don't care about wall. Okay, now the answer is what? See, 4, 4. Okay, so answer equals to 4. Now comes to the third case. Third case is what, right? We can only apply operation on 1, 2, 3. That is, this is the again my string, right? See, every time we loop over the string to get to the answer, okay? So now I can apply from 1 to 3. Only on this part I can apply the operation, okay? So count of 1 again becomes 2. Now, is there any 1 inside this, right? Any one group, right? That is surrounded, right? No, we don't see, right? So my string remains 1 0 1 0 1 0, right? So my answer equals to what? 2. This is the whatever the initial. So we return 4 4 2. Now let's see the answer, right? So this is the answer 4 4 2. Okay. Now see, now we know, right? For any, if there are like n number of groups, right? So if this is my 0 groups, right? Right. So let's say my first group of zeros, right? So the string is what, right? 0 1 0 1 0, right? That's 1 0 group, again 1 0 group, again 1 0 group, right? And count of 1 equals to what? 2. Okay. So right now what we solved is time complexity of n cross q, right? Now we need to optimize it. Okay. See, the answer is the maximum of any two subs, right? Max of, right, subsequent 0 groups. Okay, this we have already seen in the previous days, right? And I also explained this above, right? You see, maximum sum is 2, right? Count is 2, 2 plus 2, 4. This and this, right? Again 4, right? Okay. Now, tell me one thing, right? If I have something like, right, 0 0 0 1 0 0, okay, something like this. Okay, I have something like this, right? And I give you a range L to R, which is start from this index and ends at this index, right? This is my string basically. Okay, this is my string. Then I apply an augmentation, right? After augmentation, it becomes, right. Okay, let's not apply augmentation for now. So for now, let's see the, okay, L comma R is what? 1 comma 2 3 4 5. I give you 1 comma 5. It means you can only apply the operation on 1 to 5. Okay. So what can I do? I see, right, 0. Now this part, right, count of 1 is 1, right? Now in this part what is happening, right? Is there any one that is surrounded by 0? Yes. So we'll convert this to 0 0 0. Okay, these zeros remain same. This is my conversion converted. Okay. Now are these augmented? See, any substring is augmented by 1. So there is uh okay, there is a 1, right? Augmented, okay. Then can I convert them? Yes. So it becomes 0 1 1 1 1 1 0. Okay. So what is my answer for this range? It is 5. Okay. Now in this 5 you say one thing, right? This is my left group. Okay. Right, left group of zeros. And there is one right group of zeros. See, how many this left group of zeros contributed? It contributed from, right, whatever the L, right, till the end of group, right, end of 0 group, right. So what it contributed, see, I have given a L comma R, right. Now let's say this starts, right. I maintained a start and end position, right. Okay, so it contributed. First let me write one, right. block 0, left 0, right 0. Left 0 is right, left right, position of 0 group, right position of 0 group. Okay, and block 0 is size of 0 group. See, because we only care about 0 group size, and the answer is the count of ones plus sum of continuous 0 groups, right? So let me say, right, where does the 0 start? Block 0, right? First is 3, second is 3. Where they start, right? 0. What is its right endpoint? 2. Where does the second group start? 0, 1, 2, 3, 4. Okay, what is its endpoint? 4, 5, 6. Okay. Now, tell me how much this contributed, this left group of zeros, right? It contributed what? See, maximum of what? Tell me how much it contributed. See, it contributed maximum of L and this start, right? And how to find this basically? You tell me, are they always sorted? Are they always sorted? There are two ways, right? First is loop, loop over above, right? But that will again become so often, right? We don't want that. And the second is binary search. Why we can do binary search? Because these, right, zero indexes are non-overlapping, right? So whenever I move ahead, right, the index is always increase. So can I say these zero, left zero, right zero are both sorted? Okay, both, I mean increasing order, right? So then can I apply binary search on it? Yes, right, I can apply binary search on it. Okay, so if I have to find a contribution by left group, right? So what I will find, right? So I'll find, right, lower bound, right? Lower bound of what? Right? Lower bound of left on what? Right? Right size basically. I found a lower bound, right, on the right side. Let's say it gives me 2, right? Then what is the left one, right? So what I will write? So I'll write maximum of, right, L comma what? Left of 0. Let's say it gives me an index, right? Index, right? This is my position, right? Then length of 0 block equals to what? Length of 0 block equals to what, right? Whatever is the end position, right? End position is what, right? This right 0 of index, right, minus what? Maximum of L comma left 0 index, right? This is my length of, so I will take it as value 1, or let's say country left. Now similar case will happen on the right side basically, right? So on the right side, if I have to find, right, the first 0 block, right, that starts before R, then what do I do, right? I do, right, lower bound on what? Right, left 0, and lower bound of what, right? R minus 1, right? See, if R is my current index, right, I want something that starts before it. If something that starts exactly on this one, right, it, we don't count it, right? Okay, so let's say it gives me some R index. Okay, then what is my length of this block? See, what is the length of this block? You see only this thing, right? This is R. Okay, I cannot name it R, right? So I'll say R index, right? This is R, right? This I got as R index, right? Whatever the right index. So okay, we did on left, right? This I got as R index basically, this position. So what is the length of this block, right? What is the, you see, R is the our end, right? R minus what? Right? 0, right? Minimum, right? Comma L, comma R index, right? This is contribution by this one. Let's say we call it contribution, right? Now tell me anything that is then between these two, right? L and block. Let's say this is my left block. This is one, right? I have something like one, 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 something, 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 and this is my right block. Say this is my left block. So this I pass as L. This is this I give you a R, right? Okay. So it is allowed before it. Okay. And this is my art. I call this one left contribution. I call this one right contribution. Now, among these, right? And what is the index of this one, right? Let's say it left, right? Left index, and what do I say? We'll call it right index. Now, among these, right? Efficiently find, right? Find maximum in range. See, otherwise you have to loop, but how can you find the maximum in a range, right? So for that you can either use, right, sparse table or use segment tree. Okay. Now, what is a sparse table and segment tree basically? So this I will explain later. So, but let me explain you the next part, right? This will say middle country. Middle country is what we get from the query, right? Query of left comma right on this whatever the segment or sparse, right? Whatever we get. So then answer of I, right, equals to what? Maximum of what? Left country. Whatever my contribution by left, right, plus what? Contribution my middle, right, plus contribution my right, plus whatever is the count of one that I initially have, right? Okay, understand till this now? Okay, now see, one part we got few things, right? First thing is what, right? What was the first thing again? Tell me. So, right, first thing is where do I wrote this? See, we have seen the brute force approach, but in brute force we cannot do, right? So after that, what are the things that we have seen, right? Tell first thing is, right, uh, only matters, right? What matters, right? Zero blocks, right? So what do we do, right? For each zero block, right? We mentioned, right? Zero block of array, right? Left of zero, right of zero, right? These are for each block basically. For each block, right? Start position, end position. Okay. Then what do we do, right? For each query, what do we do, right? What we have to find? One, find left country. Two, find middle country. Three, find right contribution. Okay. These three contributions we needed. Now, for left country, what do we do? We do lower bound, right? Lower bound on, right? Lower bound on what? Right, zero. For right country, what do we do? Upper bound on what? Left 0. Now how to do this one? Using sparse, right? Sparse comma segment trees. Okay. So this is the approach basically. So it used a lots of concept, right? How do we prepare this zero blocks? These are using two pointers. Okay. See, this is not an, I'll not say right, this is an easy question. But I'll guarantee you, if you will by the end, right, you will definitely understand how to solve this question. Okay, let me take a screenshot of this one, right? Okay, let me save it. Okay. See, now we'll see, right? Okay, we'll see how to query sparse trees and segment trees. Okay, so before we query the sparse and segment trees, we have a zero block, right? That is like 2, 3, some 6, 2, 4. Okay, what does this 2, 3, 6, 2, 4 means? This is the length of blocks, basically, right? Length of zero block. I say any ith, right? And its index is in, so I'll say, right, left index, right index 0, 1, right? This starts from 4, this ends at 7, right? Let's say this starts at 9, and where do this end? 9, 6, what? 15. This starts at 16, where does it end? It cannot, right? It starts at 18, it ends at 20, it starts at where, right? 25, it ends at 29. Okay, now see, contribution is basically the sum of adjacent, right? Max contribution is what? Sum of adjacent. So can I create a new nums array, right? Or let's say it's gain array. It becomes, right, 2, 3, 5, 3 or 6 what? 9. Next is 6 to what? 8, 2 and 4 what? 6, right? Okay, this is my best nums or gain array. Now, if I have to ask in this range, right? This complete range, maximum contribution is what? 8. Now, how, see, we did two things here, right? We founded a left contribution, we founded a right contribution. Then middle contribution is will be founded for what? For what? Middle contribution for what, right? Left index plus 1, right index minus 2. Why we do left index plus 1, right index minus 2? Because see, the contribution of this last part, right? This part, right? This is already covered basically. That's why we only do no, not sorry, for this part. Okay, stupid arrow, but okay. But the contribution of this part is already covered when we did the this right contribution. Okay, so if we again do it, it will be double counted. Okay, that's why we do, right, our query range, right? What it is? Left index plus 1, right index minus 2. Okay, now let's see two. We have two approaches. First is sparse table. Second is segment tree. Both of these are difficult concepts. Both sparse table is also known as range minimum maximum queries, right? Used on static arrays, right? Static arrays means whose value don't change. Both, right? Static plus dynamic. See, right? Build complexity is what? Of n. Build complexity is of log n. Build complexity is of n into log of n. Same, right? This is build complexity, right? And whatever is the complexity of query, segmentary answer, this sparse table answer is O of 1. This answer is log n. Okay, now let's see. This was the my 5, 9, 8, 6. See, again new topic, right? I'm explaining very advanced topic in this one, okay? So I may say something wrong, okay? Don't judge me on this basically. Oh, because I'm tired doing this video. Okay. See, when I prepare a sparse table is basically right. In sparse table, what do we do? We talk in terms of blocks of two. We talk in terms of blocks of two. And what is segment tree? Each node, right, stores maximum of its children's. So it's like right. So what did what am I doing, bro? So I'm jumping between topics, but I'm trying to 5986. Okay, trying to explain it clearly, right? This is 5, this is 9, this is 8, this is 6. Okay, now this node, right? This node stores a sum of both. See, there's no left, right? So what will be my maximum here, right? 9, right? What will be maximum on these two? 8 comma 6, right? 8. See, what's maximum on 8,99? So if I answer you what's the maximum on 0 to 4, you answer right 9. If I ask you what is the maximum on 1 to right 0 to 1, answer is 9. If I ask you right what is the maximum on this range, what do I say? Hmm. Right, 2 comma 3. What is maximum, right? 8. 0 comma 0 is 5. 1 comma 1 is 9. See, 2 comma 2 is 8, right? 3 comma 3 is 6, right? Now, if my query is right, if I have to tell between index 1 and 2, right, then it will be broken down into, right, its child's, right, maximum of 1 comma 1, 2 comma 2, right? See, we go to the middle, right? We take a middle of both left and right, right? Then we check if this completely either overlaps or in between, right? See, 1 comma 1 is a complete, right? So this will be maximum of 9 comma 2 comma 2 is what? 8, right? Which is equals to 9. Now this query works in of log n basically. So I'll do, right, say I have given two range, right? So 0 comma 2 is easy. Let me give you 0 comma 2, right? This is your query, right? You have to tell the maximum value in this one. So what you are going to do, we first find, right, query of 0 comma 2, right? Okay, we first find the middle, right? Middle equals to 1, right? Then what do we do? See, if 0 comma 2, along with 0 comma 2 we need to maintain the array ends basically, that is 0 3. 0 3 is what? Ends, right? See, if I take middle of 0 comma 3 is 2, right? 0 comma 3 is 1. Okay, now I have two queries, right? Query 1 0 comma 2, right? The next is what? 0 comma 1. This is left query, this is right query is what? Query of 0 comma 2, right? The next is 2 comma 3. This is right query. Now see, left query is what, right? 0 comma 1, right? Now is my this 0 comma 1, right? This is my 0 comma 1, right? Is this completely inside 0 comma 2, right? Overlaps, right? Okay, so its answer will is simple, right? I can simply say it 9, because see this this entire range is overlapped, right? Because 0 comma 2, right, overlaps 0 comma 1. right? So we return it. See, other thing is 0 comma 2 and 2 comma 3. See, 0 comma 2 does not overlap 2 comma 3. Okay, so 2 comma 3 will be further broken down into two parts, right? So its left equals to what, right? 0 2 2 comma 2, and right is what? 0 2. So let me write right equals to what? 3 comma 3. See, this 2 comma 2 overlaps between 0 comma 2. Yes, right part. So this will returns me what? 8, and this will returns a maximum value, nothing. So this return me 8. So answer equals to what? Maximum of 9 comma 8, which is equals to 9. This is my answer. Okay. So this is how you query a segment tree. Now how you build a segment tree. So building is again same, right? You pass, right? You pass the entire range. Okay. Then you keep on breaking it down, right? You break it down to 0 comma 1 middle. You break it down to 2 comma 3 middle, right? Then you again further break it down. You further break it down. See, when both, right? 2 comma 2, 3 comma 3. See, when both of these are equal, right? Left equals to r. You updated with array's value, right? So you updated with what? 8. You updated with 6. You updated with 9. You updated with 5. Then, right? Then when we recursively go up, right? This node's value is maximum of these both them, right? 9. Maximum of these two, right? It again contains maximum of these, right? This is how we build. So build time is again uh, n log and what? Something, whatever. Okay, I forgot it. See, in case of sparse table, we talk in terms of power of 2. Let's say this is I have an array, right? 5986. 5986. See, if I have a 2, can I say, right? This 2 to power raised to power 2. If I jump in powers of 2, right? If I store, right? 2 raised to power 0, right? If I start from this index, current index, let's say I start from 0 and I store 2 raised to power 0, what is maximum? 9. If I do from this index, right, I start from one index, I store what's 2 raised to power, right, it's 9, right? I again go to this index, right, second index, 2, I did 2 raised to power 0 is what? 8. Next 2 raised to power 0 is what? 6 basically. See, then the next is if I am on this, right, again on 0th index, if I ask you 2 raised to power I, can I write it as 0, 2 raised to power 0, right? Maximum of comma. The next is what, right? See, base is 0, but next value is what? My current value plus the next power basically, right? This is so, sorry, this 0. 0 plus 2 raised to power 5, right? And so on. So what I do, we basically talk in terms of powers of 2. Okay. So the recursive formula is, right? So node of base. Any base from any I index is what? That is maximum of, right, node of base minus 1. See, if I write 2 raised to power 3, can I do it like, right, 2 raised to power one group of 2 raised to power 2, another group of 2 raised to power 2, right? Can I do it like this? Then I find maximum of this one, I find maximum of this one, right? Then I take maximum of total, right? So this is the same thing, right? So I start from node of base comma I. The next is what? Again node of base minus 1. Now I is what, right? See, this is my I, right? I start from this position I. I need 2 raised to power base minus 1. Then the next position it would, right? I plus 2 raised to power base minus 1, right? Then they entirely form the base. 2 raised to power base, right? So what I do, right? I plus what? Base minus 1, right? This is how to prepare a sparse table basically. Now, if I have to answer this question, right, how to answer? Now, how to query this table, right? Let's say I have asked you for range L to R. See, this is my L, this is my R. There will be powers of 2, right? Let's say there is a power of 2, 2 raised to power base, that either form like this and either that looks like this, right? So if my L equals to 1, R equals to 5, then write 1, 5. There is a power of 4, right? If we do 2 raised to power 2, which is 4, right? That extends from 1 to 4. That extends from 2 to 5, right? Then since, right, these overlap, right, I don't care. Can I take maximum this one plus this one, right? I absolutely can take on this one. Okay, so answer equals to what, right? Max power of 2, right? That is less than current, right? So what is right? This node, right? So I called this node basically. That's fine. Whatever we call it, right? So I do node of, right, log of what? R minus L plus 1 base 2, right? Base 2 will give us the length basically, that is less than equals to this one. Okay. Now start comma what? What is my end position, right? I count it from backward, right? I again say node of log 2 R minus L plus 1. See, next is R minus, right? R minus what? V minus this thing, right? Okay, 2 raised to power, right? Log of 2 R minus R plus 1. Okay, this is our answer, our query answer. So this answered in O of 1. So I hope you understand all this part, right? This is a pretty big question. See, it's complicated, but once you understand it, it's easy. So these are the entire steps that I have shown you, right? Where have I written this? I have somewhere. Okay, so this is all what you have to do. Pretty much simple and straightforward. Just please try to bear with me. And see, I cannot code this question live. It's very difficult. So I will just stop here for the day. Thank you.